Okay, so now we're going to talk about a polynomial in more than one variable. It says several variables, but if you see a polynomial in this class with more than two, I'd be a little surprised. So, I mean, it's not that you couldn't have them, I just don't think you were going to see them. But here's an example. So let's say we have 7x squared y cubed minus 17x to the fourth y squared plus xy minus 6y squared plus 9. Okay, something like that. So there's 5 terms here. 1, 2, 3, 4, 5. You can see some of the terms have an x and a y. Some of them just have a y, like this term right here. But the whole polynomial is in 2 variables, right? Well, first of all, how do you put it in standard form? There's really not much of a standard form. Like, you know, do you go by the highest x exponent or do you go by the highest y exponent? Generally, if they give me one like this, I'm just going to take it in what order they give it to me. Okay? So I'm not going to worry about which one's first. Okay? Now, each term has a coefficient. Coefficient here is 7, negative 17, 1, negative 6, and then 9, we could say is the coefficient there. Now, we know the degree of some of the terms. The degree here for that term is 0. The degree here is 2. But what do we do when we have more than one variable? Well, you add the exponents. So let's look at this one right here, the one with the 17. You're going to take 4 plus 2, and so the degree for that term is 6. And so I'm going to go to the first term now. The degree here is going to be 5. And then the degree here is going to be 2. Okay. So that's how you find the degree of a term if there's more than one variable. Now, how do you find the degree of the polynomial? So degree of polynomial, it's the highest one. Okay, so in this case, it would be degree 6 for the polynomial, because that's the highest one. And, you know, you could have 2 terms have the same degree even, but that doesn't come up a lot, but I do have to explain it. All right, well, first what we want to do is we want to be able to subtract polynomials. Let me go back up here to my example. Look at this polynomial again. Do you have any terms that you could combine? Are there any like terms? And the answer is no. None of those terms are alike. The only thing that can be different is the coefficients if they're going to be like terms. So they have to have the same variables and the same exponents. Like you might be saying, oh, I've got a y squared here and a y squared here. Yep, not good enough because of the x to the fourth. So they're not like terms. Okay, so that'll help us when we go to do this subtraction. So we have 5x cubed minus 9x squared y plus 3xy squared minus 4. Okay, now these 2 terms are not the same. You have one is an x squared y and the other is an xy squared. Okay, and then I'm going to have to distribute the minus sign, so minus 3x cubed, and I'm just writing them all out to the side, plus 6x squared y. Then it's going to be plus 2xy squared, and then minus 3. Now, if you're like, why didn't you stack them? You liked the stacking form. That's fine. Do it that way. I just didn't. Okay, so who are my like terms? Well, I've got a 5x cubed and a minus 3x cubed. Those I can combine. So that's going to be 2x cubed. I have a minus 9x squared y. Do I have any other x squared y's? Yeah, right there. So minus 9 and 6, that's negative 3x squared y. So you're combining the coefficients when they're like terms. All right, let me change to another color. I have a 3xy squared. Do I have any others? 2xy squared. That's going to be a 5xy squared. And then I just have 2 terms left, right? So a negative 4 and a negative 3, that's going to be minus 7. And that would be the polynomial that you get when you subtract the 2 polynomials that they gave us. Do I have anything else? Nope, I think that's it.